Bismillahirrahmanirrahim. Welcome back, dear students. Before power interruption, we were discussing how to find out an unknown resistance when there are we have given with the total resistance. So we concluded with that formula. Now we will proceed further for our next uh, concept, that is notation for parallel resistors, as we have used notation in series resistance by watching uh, only the formula. We can easily judge that resistances are in series, but the formula for parallel resistor is bit typical and bit difficult to write. So we normally use a particular notation to show, to represent uh, parallel resistances are parallel. For two resistance or for n resistance to be shown in parallel, R1 is parallel to R2 is parallel to R3, and this and so on so far. This process will continue. Double uh, pipe sign is shown, or vertical line is shown. Double vertical lines, two vertical marks are shown to represent resistance in parallel. So uh, this was the smaller concept. Now major concept, we are moving towards our major concept, that is application of Ohm's law. Here you can see on slide as well. Okay, back to come on. We will apply Ohm law to find the total current in parallel circuit. Things are being somewhat of repetitive nature, but they are slightly different. So we have to cover each of the topic, and total current, IT, how to find out, and then we will find each branch current, how to find out each branch current by using Ohm's law, and voltage across parallel circuit. And the last one is finding parallel resistance of the parallel circuit. So let's start. I will now come directly on formula, uh, practical practice problem, because we are now very much comfortable with the all formulas. So to quickly conclude our topic, if you will have any query that can be resolved in interactive session. So it is 100 kilo ohm and 56 kilo ohm. So R1 and R2. The requirement is find total current. How we can find total current? We have multiple plans of action for this. One plan of action is to find total current resistance RT. We have recently learned a special formula for two resistance to be in parallel. So that formula is to find out total resistance by uh, m- multiplying both and dividing by their sum. And the value here is 100 kilo ohm and 56 kilo ohm. And the sum will be like this. Now, simple formula 5600 kilo ohm. Now, kilo ohm and kilo ohm being squared and 156 kilo ohm. One quantity will be cut out, and we will left with the result 5600 over 156. If we use calculator here, 5600 divided by 156, we will be left with the answer 35.9 kilo ohm. Now, what to do? We are here for to find IT, and now we have RT, we have PT, so IT will be equal to VT divided by RT. Here we have 100 divided by 35.9, 100 divided by 35.9. The answer will be 2.785. 2.785. So, first application of Ohm law that we have find out the current uh, when we are given with resistances and voltages. Now, we the next topic is to determine next question is to determine current through each resistor in parallel circuit. I am drawing a circuit over here. So I1, I2, I3, we have to find these currents, and total voltage here are 20 volt, value is 1 kilo ohm, its value is 2.2 kilo ohm, and the value of third resistance is 560 ohm. So simple formula, as we know that in parallel voltage remains same, and we have to find out I1, I2 and I3. For I1 we will use formula Vt over R1. For I2 we will use Vt over R2, and for I3 we will use Vt over R3. And Vt here 20 over R1 is 1 kilo ohm, 20 over 2.2 kilo ohm and 20 over 560 ohm. 20 over 1 kilo ohm means 20 divided by 1000, or simply milli, it will become milli. 20 milliampere, and 20 divided by 2.2 will be answered in 9.09, and kilo will be converted into milli. Again, 20 divided by 560, this will be uh, answered in 0.00357 milliampere, or only ampere, and we will convert this answer 1, 2, and 3. Uh, I think 2, but it is. Let's start. Let's do it once again. 20 divided by 560. Yes, it is 0.035, and last digit is 7 ampere. So we have to make one more conversion. Convert it to milli, 3 decimal places, 3.5, 35.7 milliampere. So there is another question for practice. If we connect one more resistance, 9 of 910 ohm, how much current will flow through each branch? I1 will remain same because I1 is independent of any other current. I2 is independent of all other currents. I3 is independent of all other currents. So I1, I2, and I3 will remain same, as we found 20 milliampere, 9.09 milliampere, and 35.7 milliampere. Now an additional current will flow. We have to find out that current. That will be 20 divided by 910. 0.0219. So what we have to do now? Convert into milli. Answer will be I4 equal to 21.9 milliampere. Now all branch current previously present will remain same. Only I4 will be added, and impact will be on this source. This will drain out earlier than before. One thing, if we are given with multiple resistances and total current, how we can find out total voltage? We will, by using Ohm's law, we will solve this. First, draw the circuit. So it is 220 ohm, it is 560 ohm, and it is 1 kilo ohm. We have to find out Vs, and we are given with total current of 10 milliampere. Total current here is 10 milliampere. three resistances are given, and total voltage we have to find out. What would be the plan of action? First, we have to find out total resistance. And total resistance here is, we have formula of total resistance equal to RT 1 over R1 plus 1 over R2 plus 1 over R3. And 1 over R1 is equal to 1 to 20 plus 1 over R2 is equal to 560 plus 1 over 1000. So I can find out 1 over RT is equal to 1 over 220. We have to calculate again. 1 divided by 20 is equal to 0.0045, and 1 over 560, 1 divided by 560 equal to 0.0017, and 1 over 1000, we better know it is 0.001. By adding all quantities 0045, 0017, 001, so 0045 plus 17 is equal to 0062 plus 1, 0.0063. Let us confirm. Okay, this is not this is 010. It will be 0072. 45 plus 15 is equal to 60, 62, and yes, it is. So I can say, or simply I can directly solve it. Now I have value 0.0072. Now for RT is equal to 0.0072. The answer would be 1 divided by double zero, 0.0072. It is approximately 139 ohm. So RT here is 139 ohm. Now we have RT, we have IT. We can simply find out Vs is equal to IT times RT. IT here is 10 times 139 milli. So it is 1390 millivolt or 1.39 volt. Hopefully you got it. Come to the next problem. I will share the quiz with you. Now there is one more concept that we have to discuss: current sources in parallel. What about if two or more current sources are in parallel? In general, total current produced by current sources in parallel is equal to the algebraic sum of individual current sources. The algebraic sum means that you must consider the direction of current when you combine the sources in parallel. For example, I am showing you a figure on paper. All directions are upward here. Total current is 5 ampere and node A 1 ampere. So, as shown in figure, the three current sources in parallel provide current in the same direction into this particular node. So, what will happen? IT will be equal to 1 ampere plus 2 ampere, 1 ampere, 2 ampere, and this is again 2 ampere. So, total current will be 5 ampere. And if the direction, one of the current is in opposite direction to other two, the total current in node A will be changed. If I convert this current to downward, now two currents are going upward and one current is going downward. Total current will now be 1 ampere, this one, 2 ampere, this one, and minus 2 ampere, this one. So total current will be now 1 ampere. Hopefully you understand that. Now please, for the sake of practice, we are going to solve one example. Two current sources are in parallel. One is 50 milliampere and the other is 20 milliampere. Now, can you please tell me, either they are going to add or they will be subtract? Either they will be added or they will be subtracted. You are here to answer. In my opinion, you should say we cannot make a decision till when direction is given. If we are not confirmed with the direction, then we will not be able to understand either they will be added or they will be subtracted. Got it? So, if their directions are upward, they will be added. So, 50 plus 20 is equal to 70 milliampere. Okay. Now come with another example. Here, two current sources. First, we have to determine whether they are in parallel or in series. So, 10 milliampere in this branch, 10 milliampere in this branch, and 1 kilo ohm. Both currents will be are in parallel because they are connected end to end. As they are connected end to end, we say they are parallel. One thing is decided. Now, both directions also downward, so they will be added. Now, total current through this 1 kilo ohm will be 10 plus 10, 20 milliampere. We are not concerned the direction upward or downward. We are concerned the direction in all current sources would remain same. In case of opposite direction, we will subtract smaller value from larger value. Hopefully the concept is clear. Now, another concept, current divider. Like we studied voltage divider in our series circuit, we want to study current divider and we want to design current dividers in parallel circuit. In parallel circuit, total current into the junction of parallel branches divide among the branches. Thus, a parallel circuit acts as a current divider. The current divider principle is illustrated in figure. And I am going to draw it. Here you can see. Why I can say this is a current divider. Current is coming in one path and in dividing in two paths. And current of each path depends upon the resistance of that particular path. So we can say that total current IT goes through R1 and goes through R2. Partly goes through R1 and partly goes through R2. So total current divide among parallel resistors into currents with values inversely proportional to the resistance values. One thing is quite vital importance. If the resistance in a particular path is increasing, current of that path will be decreasing, or resistance of a particular path is decreasing, current of that path will be increasing. That is, the branches with higher resistance have less current and branches with lower resistance have more current. In accordance with Ohm law, if all the branches have same resistance, the branch currents will be all equal. Okay, now we are going to devise current divider formula as you saw on the slide. Here we are very well known about this formula that current of any branch will be equal to total voltage divided by that branch. I think there is no confusion here. And we also know that source voltage equal to total current times total current times total resistance. So by putting value of Vs into equation 1, here I am going to put value of Vs into equation 1. So Ix will become It times Rt over Rx. So I can clearly say the current of a particular branch is equal to ratio of total resistance to resistance of that particular branch times total current. If you know specifically, we were in series, we were doing the same practice, but formula was slightly changed. We were saying that voltage in a particular branch will be equal to that particular resistance divided by total resistance multiplied by total voltage. Here the formula is being reversed. Total resistance is divided by that particular resistance times the total current. This is CDR, current division rule, and this is voltage division rule or voltage divider formula. This is voltage divider formula and this is current divider formula. So in general, I can say that the current Ix through any branch equal to the total resistance divided by the resistance of that branch and then multiply by the total current into the junction of parallel branches. And what about if I want to find current divider formula for two branches? As I said earlier in that lecture part 1, that we will commonly counter with two parallel resistance. Then how this formula can be transformed? So keep this formula on one side. Ix equal to RT over Rx times IT. So I am keeping this formula on one side, and you better remember that parallel total resistance of two parallel resistors equal to their product over their sum. So I1 will be equal to RT over R1 times IT. If I incorporate this formula, and I2 will be equal to RT over R2 times IT. Then what do you think? What will happen? Now we will replace value of RT with this particular formula. Let's have a look. Okay, put the value of RT from this formula here. R1 times R2 divided by R1 plus R2. It is RT and left with R1 times IT. So R1 is cancelled with R1, and I can say that R2 over R1 plus R2 times IT. So formula of I1, I have to write it again. I1 is equal to R2 over R1 plus R2 times IT. And if I use same reasoning for I2, let's have a look. Put value of RT, come here, then R1 R2 over R1 plus R2 times R2 times IT. So sorry, it will be IT over R2. R2 will be cancelled with R2 and we will be left with R1 over R1 plus R2 times IT. This is the formula of I2. Now I can summarize. If I want to find out I2, I have to multiply R1 with IT divided by their sum. And if I want to find I1, then R2 multiplied by IT divided by their sum. And this particular case is only valid for two resistances. Here, uh, we will take a small pause and we'll continue with the example in next continuation of our recorded lecture. Till then, take care, keep practicing. Allah Hafiz.